This video is part of the lecture for Calculus 1, and I'm going to talk about functions. Let me start by a definition. Definition. A function is a rule. A function is a rule that assigns to each element x in a set D exactly one element called f of x in a set R. Well, let me show it to you how it looks like. So I have one set. It's the set of all the inputs. Okay. And I have another set, the set of all the outputs. Okay. And the inputs are in the set that is called the domain, and the outputs are in the set that is called range. Okay, so the set D in here is the domain, and the set R in here is the set range. Okay, and we have some elements in each of the sets. So one element x by the rule f goes to another element that is called f of x in the output set. Okay, so if the element x goes to another point or another element in the output set, then in this case we don't have the function. Okay, so that's why we say any element x in the domain goes to exactly one element in the range. Okay, so we cannot have this situation. Every point in the domain should go to exactly one point in the range. Okay, and also something that is important is that all the points in the domain should go to something, some element in the range. So we cannot have the situation that one element is alone, because the rule or the function f acts on all the elements in the domain. Okay, so x is called independent variable, and f of x, or we usually show it by y, it's called dependent variable, because this y in here, the element y, is actually depending on the element x. Okay, so we show that from the set D by the function f we go to the set R. This is called arrow diagram. The diagram that we have in here is called arrow diagram. Let me give it to you one example. Let me graph a function, x-axis, y-axis, and let me graph like some simple function like this. Okay, and just assume that this is -1, this is the point 0, this is the point 1, and just assume that this is -1/2. This point is 1/2. As you see here, if this is my function f of 1, so the element 1, which is on the domain, goes to the element 0 in the range. It's just because the value of the function at the point 1 is 0. F of 0 is also 0, but f of this point, just assume this point is, for example, 1/2. F of 1/2 is equal to -1/2. Okay, this is called the graph of the function, and we're going to talk about the graph of the function later on the next videos. Okay, now there are some ways to present a function. We're going to talk about 4 key ways to represent a function. The first one is verbally, which is basically we're going to use some words, using words to describe a function, which is not useful that much often in math. The second one is numerically. This one, we're going to use a table to represent a function. The third one is visually. And in this case, we are going to use graph. Use a graph to represent a function. And the last one is algebraically. And algebraically, it means that we are going to use some explicit formula to represent the function, using explicit formulas to represent a function. Okay, using words, we don't usually use that. This is not useful to describe a function using words. Numerically, we're going to use table. If you have some data, it would be very useful to show the function numerically. For example, in data science and some other physical problems, they're going to use a table to show it. But in calculus, we usually use a graph or a formula to represent a function. Let me give you one example for each one of them. Example. I'm going to say that I have a function which squares the inputs. Okay, and this is showing or representing the function using word. But then I'm going to use a table to represent this function. Let me graph a table. I'm going to have x's and f of x's. So the x could be, for example, 1, 2, or 4. And the description of the function says that it squares all the inputs. So if I have 1, I'm going to have 1 squared. If I have 2, I'm going to get 4. If I have 4, I'm going to get 16. Okay. Then I'm going to show it visually, which means that I'm going to use a graph. Let me graph this function. Okay. The graph of this function that squares the input would be this function. This x-axis, this is y-axis. And then, for example, as you see, at 1, I'm going to get 1. At 2, I'm going to get up to 4. This is not a very good scale, but at 4, I'm going to get 16. This blue graph is the graph of this function, and the formula that explicitly represents the function is this one: y equals to x squared. Or I can say, instead of y, I can say f of x equals to x squared. Any input gets squared. Okay. This is 4 ways to represent the function, but as I said, we usually use graph and formula in calculus. Let me give one example. And in this example, I'm going to talk about piecewise functions. Piecewise functions. What are the piecewise functions? They are defined by different formulas in different parts of their domain. In different parts of their domains. Okay? As an example, look at this function. I'm going to use a big curly bracket in here. And the function f of x would follow x squared if x is less than or equal to 1, and it's gonna follow x plus 2 excuse me, if x is greater than 1. Okay, as you see, the domain of this function is the whole r, is the whole real number. But we have 2 pieces of the function. Let me try and graph it for you. X-axis, y-axis, always label your axis. It would be very helpful. Goes up to 1. So it follows x squared. Okay. So this is the graph, y equals to x squared. And then if x is greater than 1, it's going to follow the line x plus 2. So the line x plus 2 would be something like this, okay? But after x equals to 1, it has this graph, okay? The line goes like this. But after x equals to 1, it's like that. But what happens at 1? At x equals to 1, if you plug in x equals to 1 in here, it's just because I have the equal sign in here, I need to follow x squared. So I'm gonna put a big dot in here, but when x is greater than 1, I need to have a hollow circle in here. Y equals to x plus 2, this is not included. Means that this point is not included, but this is included. Okay, very good. This is called piecewise function. Now let's talk about some elementary properties of a function. So elementary properties of a function. Let me start by defining even functions. What is an even function? We say that the function f is even if and only if. So this notation is called if and only if. It means that they are equal to, they are equivalent. If f of negative x is equal to f of x for all x in the domain of f. Okay, so what it says, this formula in here, f of negative x is equal to f of x, it says that the graph of f is symmetric with respect to the y-axis. Let me write it for you. The graph of f is symmetric with respect to the y-axis. As you see, the value of the function at these two different points, x and negative x, we get the same function. Let me give you two examples. One, this is 2. This is y-axis, x-axis. This is x-axis. And for example, y equals to x squared. As you see, this function is symmetric with respect to the y-axis. For example, at the point negative 2, we get 4. And also at the point 2, we get 4. So f of negative x, negative 2, is equal to f of 2. Okay. Another function would be this function, absolute value of x. Okay. As you see, f of negative 2, for example, it's 2, and f of 2 is also 2. Okay. This function is also symmetric with respect to the y-axis. This is called even function. How about odd functions? What is an odd function? We say that a function f is odd if and only if f of negative x is equal to negative f of x. Okay, that's the difference between these two. For all x in the domain of f. Okay, and in that case, this formula in here shows that the graph of f is symmetric about the origin. The graph of f is symmetric about the origin. About the origin. What it means? It means that after rotating by pi radians, we get the same thing. It's the same after rotating about, after rotating by pi about 0, 0. Let me give you two examples of this one as well. So, y-axis, x-axis, y-axis, x-axis, and look at this graph. Y equals to x cubed. As you see, if I just rotate this part about the origin and I come in here by pi radian, then I get to this point. So this is symmetric about the origin. Another example would be this graph. This is called sine of x. This is a trigonometric function, and we are going to talk about them later in the course. But if we just rotate this part of the graph and then rotate it by pi radians, I'm going to go into this part. So both of them are odd functions. Okay, very good. Another property of a function that it's good to know is this one. We're going to say f is increasing on the interval I if x1 is less than x2 in I, then f of x1 is less than f of x2. Look at this notation in here. This is called implies, and we usually use then to say it in words. So as one good example of this would be, for example, look at this function. This function is called square root of x. And as you see, for example, I picked 2 points, 1 and 2. 1 is less than 2 in the interval from 0 to positive infinity, for example. 1 is less than 2, and f of 1 is 1. F of 2 is the square root of 2, 1.4. And as you see, f of 1 is less than f of 2. If you pick any point that is less than the other point, any x1 less than x2, then we get f of x1 less than f of x2. It's an increasing function. As you see, if we go along the positive x-axis like that, if we go like this, then the function is increasing, as you see in here. Then on the other hand, we say f is decreasing on the interval I if x1 less than x2 in I, then f of x1 is greater than f of x2. That's the difference between these two. Okay? As an example, look at this function. X-axis, y-axis, and this is just the part of the function x squared. And pick 2 points. For example, the point -1 and 0. -1 is less than 0, but f of -1 is 1, which is not less than f of 0, which is 0. So -1 is less than 0, and f of -1 is greater than f of 0. This is 0, this is 1. So as you see, this is a decreasing function. Okay, let me give you just one more example. Look at this function, for example. Okay, so this is y-axis, x-axis, and the graph looks like, looks like this. As you see, the graph from the origin up to this point, A, B, and just assume that the last point is C. So the graph on the interval from 0 to A is increasing. From A to B, the graph is decreasing. And from B to C is also increasing. Okay, so we're gonna say that the function f in here from 0 to A and on the interval from B to C is increasing. We're not gonna include the endpoints because we need to be a little careful about them. We're gonna talk about them later. And from A to B, on the interval from A to B, the function is decreasing. Okay. That's everything about increasing and decreasing functions. And we're going to talk about the range and domain and more properties of the function on the next lecture.